Unpeeled. We're going to look at 3D printed golf clubs, a 3D printed femur or part of a femur and a pelvis, India's first powder bed fusion system, and well, a metal 3D printing technology from MIT that's probably not so new as they want to make us believe. First, yeah, Cobra King 3D printed putters were on the market already. Now the company's gone further. We're using HP Multijet for a total of 8 different models of club. And now that's a good thing because everyone can do just one little putter, just a validated technology or to be cool and to make a press release. The fact that making 8 different models of Agera and a couple other names using 3D printing technology is wonderful news. The clubs cost about $349. The inserts they have inserts in them that you can change depending on what weight you want. And they say that the 3D printing makes the weight distribution better, improves the feel of the club, and the performance and the sound of the club. So I think that's absolutely wonderful that it could do those things at the same time. And I really think that golf clubs, being a relatively small object that can be really optimized, is one area where I really, really want to see this advance significantly. I'm seeing this advance significantly, and I think yeah, that's really good. They look kind of cool as well. They've got lots of other technology and things on them, including some parts by LA Golf and other things like that. But yeah, I think this should be a very, very mainstream technology in the golf business going forward, and we'll see if it moves beyond putters and Cobra towards every other company. Pretty much every big golf company has kind of tried 3D printing. But it kind of stalled. A couple of years ago, they were just trying it. Every company was working on it. And now very few have actually taken it into production and really are running with it. So I think the Cobra guys are really the ones to beat at the moment. So the next bit of news has to do with the really cool news. I think actually it's an SLS printer, powder bed fusion printer by STPL 3D called the Vinmec INS 500. It's got a 100-watt CO2 laser, 500 by 500 by 500 meter build volume, and weighs a whopping 2 tons, by the way. And it's India's first powder bed fusion printer. So this is good news. I think it was, there were some good news noises as well from Indian politicians, things like that. India has been trying to do a high-tech manufacturing at home type of push, going into stuff that's low volume, high volume, but kind of relatively easy, like assembling iPhones, and wanting to do stuff like semiconductors and stuff on the same end as well. And of course, an Indian-made 3D printer really fits into this. I think there's also a logic to this. This isn't some vanity project. This is great because if you're an Indian defense company or some kind of defense-related or space-related company, you're going to want to use this system because you're going to control it. You're going to trust these people because they're your fellow countrymen. And so there's a great, apart from the nationalism, which could cause people to buy this as well, there is a great business case to using and buying your own 3D printer, especially in a world where we see that now, for example, Switzerland is not yet letting ammunition for some of its vehicles be used in Ukraine. Other companies are running out of certain equipment and gear and unable to repair it. So I think in total, I think what you want to see is a lot of stuff where people or what we're going to see is a lot of stuff where people are going to develop their own 3D printers for a certain country. And it's, I think countries like Vietnam, countries like, we would expect more activity in Korea, but there is stuff going on in Korea, more activity in Japan, but there's stuff happening there. But also other kind of like countries that, could do it technologically speaking and economy-wise, especially in Asia, where we'll see more developments of this kind. I think Vietnam really, really makes sense. And India, of course, makes sense given the size of the country and given the opportunities it has in manufacturing and the opportunities it has shown in space as well by developing a successful space program. So this is good. The next news, it's actually also from Vietnam. So it's from the Vinmec International General Hospital. They had a patient who had a trauma, cancer-related trauma in the pelvis, part of the femur. These things for traumatology and for cancer, specifically oncology-related traumatology, 3D printing has been used for a while already to make implants, some case polymer ones, some case metal ones. It's all really kind of custom, and it's usually only done when there are no good other options, essentially. And in this case, it was a super difficult surgery. It was really difficult. The chances of this guy were very, very low, and they ended up having to design an implant in Vietnam. This time, they shipped off to Germany for it to get it and to get it made in Germany. But going forward, I think that thing surely in the future is going to be 3D printed in Vietnam. Also, what's also interesting is that one of the goals of the research team, the university, and the hospital is to develop, of course, implantology in Vietnam. I think this is a really, really great idea. It'll save them a lot of money as a country and a health system. It's a way for them to create an industry that's really, really high value. We know that Vietnam is a really strong country in manufacturing low end goods, and it's becoming a stronger country in manufacturing higher end goods. It could very well, the investment in making, if we're talking about just doing a center that can 3D print implants, the investments in the tens of millions, low tens of millions are there to do that. And that's not something that they can't do, or they can't do several times over if they really wanted to lead the world in implants. So I think this is a really fantastic thing for them to do, given their own volume, given their population, and given the way they want to be ahead of us, everyone else on the tech tree, essentially. So I think the next one of these should be doing in Vietnam, and hopefully they'll invest some money in making this technology bloom there. If not, they're missing a big opportunity, because the burgeoning populations in Asia, the fact that these countries and certain segments of population in these countries are getting more wealthier, living longer, all that kind of stuff leads to a really high incidence of need for all sorts of implants. And especially titanium implants, which this is one of them, and especially kind of custom ones, but also just ones throughout the body. So I think it would be really smart of them to invest and create some local companies and centers and research centers to do specifically trauma, but also those orthopedic metal implants. I think that'd be really good. Also, because it has a lot of, if you can make an implant, you can also high-tech manufacture a ton of different stuff. The next thing is a MIT process, which rather confusingly is called liquid metal printing. We've seen several different liquid metal printing technologies as well. The researchers behind this are really known people. Scarlett Tibbets is very well known. Zane Carson, Kimball Kaiser, Jared Laux. They're known people at MIT, a known lab at MIT. It's being somehow presented in some media sources, some releases, as being kind of like they invented this technology, which, if we look at it, doesn't really seem like it's the case. But they have a different kind of variant of this technology. And essentially what happens is aluminum billet or aluminum bulk material is put in an electronic furnace. The coils are heat this to 700 degrees Celsius. It's then put into a crucible, and then it's fed through a nozzle, and it goes into a print bed. Now, that, of course, is a lot similar to the Grobe technology developed in Germany by the company, the machine tool manufacturer Grobe. It's very, very similar to Valkoen, which is a Belgian-made technology that also melts in a crucible and also drips. They drip differently, but they're very, very similar. And of course, it's similar to the Vader technology that was previously tried to be commercialized by Xerox. So, maybe just the press people getting a little bit ahead of themselves. I like to think it's that. Now, what they have done that's quite interesting is they deposit these things in 100 micron glass bead print bed. Now, that's kind of a really nice material that withstands this high heat, 700 degrees Celsius or more, high heat aluminum, and acts kind of like as a support without A, getting stuck to everything, or B, getting kind of coating everything, or ruining the print, or just distorting the print. So that to me is super interesting. They positioning this as rightfully so as a low cost, low resolution, high speed technology. So it could compete with the aforementioned Grobe and Balcoon and stuff like that, Meltio, stuff like that. These technologies are all working on parts that are maybe not pretty, maybe not really good definition, wall thickness is not thin, not really good details, but are super duper cheap. And what I love about this, the thing I love most about this is the examples they have here. Is they have some really cheap looking, kind of regular looking, kind of like furniture. And these are the things we can do. And now we're always thinking of like, oh, okay, maybe we mill down the furniture and then we make it look all shiny, like normal metal and normal furniture. But maybe we use this as a feature, right? Maybe people will love this kind of really rough aesthetic, or maybe people won't mind if it's cheap and you can make a custom made chair that's exactly the right size for you. I love these examples. I love this as a really cheap example, and I hope they go ahead with this and make this a low cost, or another path to low cost aluminum 3D printing. I think aluminum has been very difficult for us traditionally to 3D print. Now we can do it on e-beam and green laser, and also with some hacks on non-green laser. unpowdered bed fusion. It's still not cheap though. Meltio and Valcoon and Grove are the only ways to really make cheap aluminum parts at the moment, um, at scale. And anyone doing something else could really, especially in austere environments or especially in really low cost kind of application, could really, do some really trailblazing stuff here. So thank you for listening. My name is Joris Peels. This was another 3D printing unpeeled. Thanks to 3D.